in the deep stillness of space, where silence is not the absence of sound, but the sound of eternity itself. A faint shimmer of light drifts across an ocean of nothingness. It is a ghost of a photon, ancient beyond comprehension, born in the first breaths of the cosmos, and now arriving at the edge of our understanding. That fragile spark of illumination has traveled for more than 13 billion years, carrying within it a secret that defies the order of everything we thought we knew. It is not a whisper from a distant star, but a message from a time when the universe was still young and uncertain, when the first atoms of hydrogen were learning how to burn. This light, caught by the golden mirrors of the James Webb Space Telescope, would change the story of creation itself. Through the lens of James Webb, humanity peered deeper than ever before, reaching back to the dawn of time. In its first deep field images, among 1,000 pinpricks of ancient light, there appeared a galaxy unlike any other, vast, luminous island suspended in the fog of cosmic infancy. The data came back clear and unrelenting. This galaxy, known as GLASSC13, existed only a few 100 million years after the Big Bang, when the cosmos should have been nothing more than darkness and dust. Yet there it was, mature, structured, burning bright with starlight that should have taken billions of years to exist. Its spiral-like pattern and dense stellar population were not the marks of something new, but of something impossibly old. Astronomers stared at the image in disbelief. The universe, as they understood it, could not have made this. There had not been enough time for stars to fuse, explode, and forge the heavy elements that build galaxies. There had not been enough gravity for such massive structures to gather, nor enough cooling for light to ignite in such brilliance. Every model, every equation, every simulation of cosmic evolution trembled in the face of this silent contradiction. Either the telescope, the most advanced human instrument ever built, was wrong, or the universe itself was breaking its own laws. The discovery did not arrive with fanfare, but with quiet shock. It was a revelation that felt like heresy, a moment when the ground beneath scientific certainty shifted. For decades, cosmology had been a story of steady progress, a universe expanding, cooling, evolving according to predictable rules. But this galaxy stood as a defiant anomaly, whispering of a reality that might be far stranger, faster and older than we dared to imagine. The light that reached us from that impossible dawn was more than a signal, it was a paradox, frozen in time as scientists began to trace its meaning. The question deepened: if the laws of physics are the language of the universe, what happens when the cosmos begins to speak in another tongue? Somewhere in the silent mathematics of creation, an unseen variable awaited discovery. Perhaps time itself had played differently in those first epochs. Perhaps gravity had woven its web with a different thread. Or perhaps the story of the universe was never as linear as we believed. And so began a new kind of cosmic mystery, one that would question not only the birth of galaxies, but the very foundation of time, matter, and the story of everything. In the cold vacuum beyond the moon's orbit, where sunlight fades into silence and starlight becomes the only truth left to measure, a golden eye was opened to the ancient sky. The James Webb Space Telescope, an instrument 30 years in the making, born of human doubt, ambition, and fragile precision, drifted to its station 1 million miles from Earth. There, at the second Lagrange point, balanced between gravity and eternity, it unfolded its gold-plated mirrors like the petals of a cosmic flower. Each hexagonal segment reflected not just light, but time itself, bending the faint whispers of the early universe into focus. Designed to see beyond the reach of any telescope before it, James Webb would look not at stars as they are, but as they were billions of years ago, in an age when the universe was still forming its first constellations of meaning. Its eyes were tuned to the infrared spectrum, the language of heat and dust, the hidden glow of creation itself. With that gift, it would pierce through the cosmic fog that had shrouded the first galaxies since the dawn of light. When the first deep-field image arrived, humanity held its breath. The frame was a smaller patch of sky, no bigger than a grain of sand held at arm's length. Yet within it burned thousands of galaxies, each one a universe of stars, gas, and time. It was not just a picture, but a revelation. The early cosmos was far richer, more structured, and more alive than anyone had dared to imagine. These were not faint, formless clouds struggling toward existence. They were mature systems, brilliant, massive, already sculpted by gravity and light. The image defied the narrative of slow, orderly creation. Instead, it hinted at a cosmos that had rushed to grow, condensing chaos into beauty at impossible speed. Scientists stared in silence, aware that in this single frame, centuries of theory stood at risk. Then came the anomaly. Among those myriad points of light, one stood out a distant, red-shifted galaxy catalogued as GLAS SC13. Its color revealed its age. Light stretched by the expansion of space until only the faintest infrared trace remained. Yet when the data were decoded, the truth struck like lightning. This galaxy existed a mere 300 million years after the Big Bang. When the universe was still in its infancy, yet it carried the mass and brightness of systems billions of years old. It should not exist. There had not been enough time for stars to be born, to live, to die, to forge the heavy elements needed for such structure. By every physical law known, this was impossible. The early cosmos, according to all simulations, should have been a dark ocean of hydrogen, punctuated only by the first flickers of starlight. But here was an island of brilliance, complete and ancient before its time. At first, the scientific community hesitated. Peer review demanded caution. Could it be an illusioning, error in measurement, a trick of cosmic dust, or a lensing effect bending light from something closer? But as the weeks passed, more observations confirmed the finding. Independent teams using different models and instruments reached the same conclusion. The redshift was real, the light authentic, the object undeniably ancient. The anomaly had survived scrutiny, and with that, disbelief gave way to quiet unease. If this galaxy truly existed so soon after the Big Bang, then the foundations of cosmology were incomplete. The scale of the problem became staggering. The timeline of the universe's evolution, carefully built from decades of data, no longer fit. To form a galaxy like this, stars would have needed to ignite almost immediately after cosmic expansion began, collapsing from hydrogen clouds at speeds that defied gravitational limits. Those stars would then need to burn, explode, and recycle their elements into second-generation suns, all within a cosmic blink. The chemistry of creation, thought to unfold over eons, would have to be rewritten as an event of almost violent urgency. The laws of matter, thermodynamics, even the expansion of space itself, seemed to require revision. Behind closed doors, scientists began to whisper. They spoke not in press conferences or papers, but in the quiet of observatories and message threads late at night. Some wondered if the universe was older than we believed. The expansion rate, and therefore our cosmic clock, had been misjudged. Others considered that the nature of dark matter or dark energy might be different in the early epochs, allowing galaxies to condense faster than current models allow. And a few, those unafraid of the fringe, asked the question no one wanted to face. What if time itself behaves differently across the fabric of reality? As James Webb continued to stare deeper into the unknown, more such galaxies began to appear. Each one a defiance, a question carved in starlight. The narrative of the cosmos, once stable and linear, began to ripple with uncertainty. Perhaps the universe was not a story told in order, but a mosaic of overlapping beginnings. Perhaps the early universe wasn't as young as we thought, or perhaps, in that ancient dawn, time itself flowed differently. In the months that followed the first revelation, the silence of space grew louder. The universe, once thought to be mapped in theory and time, began to murmur of deeper complexities. The James Webb Space Telescope continued its watch, its golden eye gazing across cosmic epochs, peeling back layers of creation that had remained untouched since the beginning. With every new image, the same paradox returned: galaxies appearing where none should be. Colossal structures shining with the maturity of billions of years, though the cosmos itself had barely begun. One anomaly became two became a dozen, and soon astronomers found themselves surrounded by impossibilities. The universe, it seemed, had written its first chapter far faster than any human equation could allow. Each new observation landed, like a tremor, through the foundations of cosmology. Galaxies labeled Sears 174, Maisie's galaxy GHC2, and others scattered across Webb's deep field. Mosaics all carried redshifts so high that their light had traveled from the edge of time. These systems were massive, luminous, and structured, their starlight echoing from an era when space should still have been dark and chaotic. The discovery was no longer a curiosity. It was a crisis. The cosmic model that had guided astronomy for decades, Deco-made model, or lambda, cold dark matter, began to show cracks. It was a model built with elegance and precision, predicting the slow formation of galaxies under the influence of dark matter, the steady expansion of space under dark energy, and the cooling of primordial plasma into hydrogen and helium. Yet, before Webb's gaze, this framework began to tremble. If the CDM model were correct, then the early universe should have been a cosmic nursery, fragile and turbulent, producing small and irregular galaxies that would only later merge into grandeur. But the Webb telescope revealed giant galaxies, hundreds of times more massive than expected, with rotational symmetry, dust, and chemical enrichment far beyond their supposed age. The data did not simply stretch the model. It threatened to undo its logic entirely. It was as if the universe had skipped chapters in its own evolution, revealing a sudden maturity where infancy should have been. Some scientists called it cosmic evolution on fast forward. Others whispered that perhaps our understanding of the beginning itself was incomplete. The redshift values, the cosmic fingerprints of distance and time, became the heart of the debate. Redshift measures how light is stretched as the universe expands. The higher the value, the older the light. Yet, as more ultra-higher redshift galaxies appeared, some astronomers began to question whether redshift alone could tell the full story. Could space itself behave differently in the first billion years? Could light have traveled through a medium that distorted its message, bending time and color in ways no model predicted? Some proposed that early dark energy or variations in cosmic inflation might explain the illusion. Others suggested that the expansion rate of the universe, known as the Hubble constant, might not have been constant at all. The debate deepened into philosophical territory, where even the nature of distance and time became uncertain. Amid these mysteries, another puzzle emerged from the depths of Webb's infrared vision: black holes. Not the scattered remnants of dead stars, but colossal entities, millions, even billions of solar masses large, already anchored at the centers of these infant galaxies. They existed impossibly early, suggesting that either matter had collapsed faster than gravity should allow, or that black holes had formed through mechanisms still unknown. Some theorized direct collapse, black holes born not from dying stars, but from the raw gravitational implosion of primordial gas clouds. If true, this would mean that the first lights of the universe had risen around darkness itself, that creation began not in stars, but in shadows. And then came the metallic whisper, one of the strangest revelations of all. Spectral analysis showed that these early galaxies contained heavy elements like oxygen, carbon, and iron metals that could only have been forged in the hearts of dying stars. Yet, for those elements to exist so early, countless generations of stars must have lived and died in mere cosmic moments. The early universe, it seemed, was not just forming, it was burning, recycling, and evolving at a speed far beyond comprehension. The chemistry of creation was happening in overdrive, hinting that the cosmos itself might possess mechanisms of growth we have yet to understand. As the evidence mounted, the astronomical community divided quietly. Publicly, papers were cautious, carefully worded with terms like unexpected, unexplained, or anomalous. But in private discussions, a different tone emerged. Scientists began to speak of new physics, of the possibility that something fundamental, hidden beneath equations and constants, had been overlooked. Perhaps dark matter interacted with itself in strange ways. Perhaps dark energy wasn't constant but changed with time. Or perhaps, in the universe's first instance, the very laws that govern energy, gravity, and light were still forming, still deciding what kind of cosmos they would become. The mystery deepened, not as chaos, but as revelation. Each new image from James Webb was not a contradiction, but a reminder that our understanding of the universe is not a fixed truth, but a moving horizon. The more we see, the more we realize how little we know, and so the search continued, guided not by certainty, but by curiosity, the same force that once lifted eyes from the soil of a young Earth to the stars. The anomalies were no longer single errors in data. They were the first glimpses of a deeper pattern, the whisper of a universe speaking in a language still beyond our comprehension. To understand the impossible, one must return to where it all began, to the birth of light itself. But as the data deepened, so too did the silence in the rooms where the universe was being reinterpreted. In dim observatories and digital meetings across continents, astronomers stared at screens glowing with light older than galaxies themselves, unable to reconcile what they saw with what they knew. Each new dataset became a quiet confession. The cosmos was not obeying its own script. The numbers aligned perfectly with observation, yet tore away from theory. For a science that had grown accustomed to precision, this was not merely unsettling. It was transformative. The early universe had always been considered a clean equation, predictable, traceable, logical. But James Webb was showing a cosmos that behaved like art, not arithmetic. In those deep fields, time seemed to behave like a liquid, folding and pooling in unexpected ways. Some astrophysicists began to wonder if cosmic expansion might not have been uniform, if space-time itself, still cooling and settling from inflation, could have rippled unevenly, creating pockets where gravity sculpted structure faster than elsewhere. Others reached even further, suggesting that quantum fluctuations at the dawn of existence might have seeded entire regions of overdensity, creating islands of accelerated creation where galaxies could form in a cosmic instant. These were not wild fantasies, but genuine attempts to reconcile data with reality. New mathematics. blooming from the cracks in the old universe. The galaxies themselves told stories that seemed older than their light. Their stars were too red, their dust too thick, their halos too organized. It was as if they had already lived lifetimes before their photons began the 13 billion year journey to Webb's mirror. The telescope, with its golden petals open like the eye of a god, had not just captured ancient light, it had captured ancient memory. And within that memory, hidden in wavelengths invisible to human sight, lay a message. The universe had grown up faster than anyone imagined. Even the skeptics, the defenders of the standard model, found themselves retreating into caution. Peer reviews no longer dismissed the findings, they only softened their implications. Perhaps our assumptions about star formation rates are incomplete, one paper would say. Perhaps dust obscuration biases our understanding of mass, another offered. Yet behind every word lingered the same unspoken admission. Perhaps we are missing something profound. Perhaps the universe is not a patient architect, but a restless one. What troubled scientists most wasn't just that these galaxies existed, was that they appeared everywhere. The more Webb looked, the more it found. Every deep field, every corner of sky held the same strange abundance. Statistically, it should have been impossible, and yet the impossible had become common. The universe was whispering that our map of its infancy was wrong, that we had measured its pulse incorrectly. Some researchers began exploring the idea that our concept of time itself, our measure of cosmic age, might be flawed. Perhaps, they speculated, the rate at which the universe expanded was not smooth or linear. If expansion had slowed briefly after inflation, it could have allowed matter to clump faster, birthing galaxies in what we now mistake for an impossibly short time. A fleeting pause in cosmic growth. Just a few million years could have rewritten everything. We think we know about the chronology of creation, and beneath those, equations and simulations lingered a quieter question, one less about math and more about meaning. What if our perception of cosmic order is itself limited by our place in time? What if the universe's earliest moments were not governed by the same constants we measure today? The speed of light, the strength of gravity, the flow of entropy all may have been in flux, shifting like tides in a newborn ocean. The laws we call universal may have only become universal after the universe itself had time to decide what it would be. So, James Webb continues to stare into the darkness, and the darkness stares back, filled with structures too grand, too ancient, too luminous for comfort. Each discovery feels less like an answer and more like a question unfolding into deeper mystery. Somewhere buried in those red galaxies, shimmering at the edge of time, lies a truth older than the Big Bang's equations, a truth that refuses to fit into the neat boxes of our understanding. And as that truth approaches, the tone of science shifts. The awe that once belonged to poets and dreamers returns to the laboratories of physicists. For the first time in decades, cosmology feels uncertain, again, therefore alive. The mystery has not weakened science. It has revived it. The early universe, it seems, is not a static relic of creation, but a living riddle, one that changes every time we look deeper. The stars that should not exist now illuminate the path forward, not as contradictions, but as invitations. They remind humanity that knowledge is not the end of wonder, but its beginning. And somewhere beyond those galaxies, beyond the veil of time itself, the universe is still becoming, still writing its own origin, one photon at a time. In the beginning, there was only darkness, not the kind born from the absence of light, but the kind that precedes creation itself. A vast, formless ocean of hydrogen stretched across the young cosmos, silent and opaque. Time itself was barely awake. Gravity, the quiet sculptor of existence, began its slow and patient work, gathering invisible clouds into knots of pressure and heat. And then, somewhere in that endless black, a single point of radiance bloomed. The first star ignited. The era known as the cosmic dawn had begun. These first suns were unlike any that shine today, enormous, volatile, and fleeting. They burned with the raw fury of untouched creation, fusing primordial hydrogen into the first heavy elements, carbon, oxygen, iron, the seeds of everything to come. Their deaths were cataclysmic, scattering metals into the void, lighting the path for galaxies to grow. Over a few 100 million years, the universe transformed from darkness to brilliance. The fog of hydrogen cleared, a process astronomers call reionization, and the cosmos revealed its structure for the first time. Galaxies clustered like constellations of thought, stretching filaments across the infinite. It was the dawn of everything we would one day come to see. For decades, scientists have hunted this elusive frontier, the birth of light itself. The Hubble Space Telescope, with its silvered eye, reached back nearly 13 billion years, capturing faint red smudges that hinted at the first galaxies. But even Hubble, for all its triumphs, was blind beyond a certain point. The earliest light had been stretched by the expanding universe, redshifted beyond visible wavelengths into the infrared, a spectrum that Earth's atmosphere and older telescopes could not clearly see. Humanity stood on the edge of the veil, staring into a darkness that was not empty, but hidden. Then came the dream of a new machine, one that could pierce the fog of time. The James Webb Space Telescope was not built merely to see farther. It was built to see deeper, to trace the faintest whispers of infrared light that had been traveling since the dawn of the universe. Every part of it, every screw, every mirror, every calculation was designed for that single purpose, to reach the unreachable. Its mirrors, coated in pure gold, reflect light with near-perfect precision. Its sun shield, the size of a tennis court and thinner than a human hair, unfolds like a mechanical flower in the vacuum of space, protecting the telescope from the heat of the sun and Earth. And its home, a gravitationally balanced point called L2, allows it to drift in eternal night, 1.5 million kilometers away from the planet that built it. There it orbits the dark, staring forever outward. It took 3 decades of human patience and engineering audacity to create this instrument. Thousands of scientists, engineers, and dreamers worked across continents through failures, delays, and political storms to construct a telescope that could not afford a single mistake. When it finally launched on December 25, 2021, it carried not only the hopes of a generation, but the weight of our cosmic curiosity, and when it opened its golden eye to the universe, the results were immediate and staggering. The first deep-field image was not a single photograph, but a portal. Within a tiny patch of sky no larger than a grain of sand held at arm's length, James Webb revealed thousands of galaxies, each a city of billions of stars, shimmering in infrared hues never before seen by human eyes. Some were warped by gravity, some stretched into arcs by cosmic lenses, and some, impossibly, appeared far too ancient to belong to that early age. At first, skepticism ruled the conversation. Perhaps the redshift data was wrong. Perhaps the galaxies were closer, their colors distorted by dust. The scientific method demanded caution. Papers were written, models adjusted, calibrations rechecked. But as Webb continued to observe, and as other instruments, including the Atacama, large millimeter array, and spectroscopic analyses, confirmed the findings, Doubt turned to wonder. This was no illusion. The impossible galaxies were real. In conference halls and private messages, the discussions grew quieter, more hesitant. How could the early universe have produced such complex structures so quickly? How could so much mass accumulate in so little time? These were not errors. They were contradictions, ones that struck at the very foundation of cosmology's most trusted model, the theory that had guided decades of understanding. For the first time since the discovery of dark energy, the pillars of cosmic history trembled. James Webb had not only shown us more of the universe, it had shown us that we might have been looking at it through the wrong lens. And in that moment, amid the flood of data and debate, a strange beauty unfolded, the beauty of being wrong, of realizing that the universe still holds secrets vast enough to humble our equations. The discovery was not just scientific, it was existential. Humanity, standing at the edge of the known, had once again found itself staring into the unknown. Yet, as the questions multiplied, so did the resolve. Teams around the world began new simulations, fresh theories, revised models. Could early star formation have been faster? Could dark matter behave differently at high energy scales? Could physics itself have played by different rules in the primordial past? Each answer led only two more questions, and each question led deeper into the mystery. The James Webb Space Telescope had not simply observed the early universe, it had forced humanity to confront the possibility that its beginning might not be as young, as simple, or as understood as we once believed. It had done what all great discoveries do. It turned knowledge into wonder. And yet, as this revelation rippled through the scientific world, one truth remained constant. The cosmos was not finished telling its story. For every explanation, the light from those ancient galaxies whispered new contradictions, new riddles waiting beyond the reach of gold mirrors and human minds. Because the universe, it seems, does not just reveal itself to those who look. It changes every time we dare to see it more clearly. But the deeper scientists looked, the more the light seemed to bend around certainty itself. Each observation peeled away another layer of assumption, as though the universe were deliberately hiding its origin behind a maze of illusions. The further back James Webb gazed, the stranger reality became. Spectral lines, those cosmic fingerprints of chemical identity, showed unexpected complexity. Hydrogen and helium were present, as expected, but faint traces of oxygen, carbon, and even nitrogen glimmered within the spectra of galaxies that should have been too young to forge them. These elements required generations of stars to live and die, scattering their ashes across the void. Yet here they were, woven into galaxies that had barely had time to exist. It was as if creation itself had accelerated, compressing eons into moments, sculpting complexity at impossible speed. In laboratories and observatories across Earth, the data continued to pour in. Teams calibrated instruments, ran simulations, and compared models, yet the numbers refused to align with expectation. Some researchers suggested that the first stars, the population, 3 stars long theorized but never observed, might have been far larger and hotter than predicted, burning their fuel in violent haste and seeding the cosmos with metals far earlier than imagined. Others speculated about dark matter behaving differently in the high-energy conditions of the early universe, collapsing structures faster and deeper than standard cosmology allowed. And there were those who whispered that perhaps our understanding of expansion itself, the very stretching of space-time, was incomplete. Maybe the clock of the universe did not tick as steadily in its infancy as it does today. As these possibilities unfolded, the engineers who had built Webb found themselves watching their creation evolve beyond its mission. It was no longer just a telescope, it had become a time machine that questioned the very flow of time. Its sensors, chilled to near absolute zero, captured light that predated the Milky Way. Yet the data it sent home ignited the most heated debates in modern science. Every image was both a triumph and a taunt, proof of human genius, and a reminder of how much remains unseen. The astronomers themselves were not untouched by the emotional gravity of it all. They spoke quietly of the feeling that the cosmos was not a solved equation, but a living, interchanging, unpredictable, aware in its own silent way. The awe was mixed with something else, unease. To glimpse the first galaxies was to touch the moment when reality was still raw and unfinished, when laws were still settling into place. And now, it seemed, those laws were whispering that they might not be eternal after all. The legacy of discovery stretched backward through time. Galileo, who once turned his telescope toward the sky and defied the doctrines of his age, would have understood this moment. So would Edwin Hubble, whose own observations first revealed that the universe was expanding. Each generation of explorers had faced its own paradox, its own moment of doubt. James Webb had simply carried that lineage further so far, in fact, that the universe itself now seemed to be asking a question in return. And so the scientists listened, searching for meaning in wavelengths and ratios, in curves of redshift and brightness that danced on their screens like coded messages from creation. Somewhere in that ancient light lay a truth about beginnings, truth that no theory yet could hold. The numbers did not lie, but they also did not explain. The mystery, it seemed, was not only about what the telescope could see, but about what the human mind could understand. For all its precision, James Webb had shown something far more profound than data. It had shown that the cosmos is not a closed story. Every discovery is a doorway, and beyond each doorway lies a deeper question. The birth of galaxies, the flow of time, the very act of seeing all were now bound together in one unfolding enigma. And as the light from the first dawn continued its long journey toward us, humanity stood once again at the edge of knowledge, reminded that every step forward into the dark reveals not just the universe, but the mystery of our own need to know. In the dim glow of laboratory monitors, the universe felt closer than ever and yet further away than it had ever been. On screens filled with full-color images and streams of spectral data, light from the dawn of time flickered in silent defiance. It was evidence so sharp, so clear, and yet so incomprehensible that it fractured the scientific world into two states of being, belief and disbelief. For some, the numbers could not be trusted. They were statistical ghosts, misread by instruments or misinterpreted by eager minds. For others, they were revelations, proof that the cosmos had been whispering a different truth all along, waiting for a telescope bold enough to listen. In the great halls of astrophysics, disbelief was not born from arrogance, but from reverence. The CDM model, the lambda cold dark matter paradigm, had stood for decades as the foundation of cosmology. It described the universe with elegant precision, weaving together dark energy, dark matter, and the cosmic microwave background into a coherent narrative. It had predicted the structure of the cosmos with uncanny accuracy, and from it, humanity had charted the history of existence itself. To question it was not simply to challenge a model, but to unsettle the story of reality that generations had built their lives upon. For many scientists, that weight was suffocating. To consider that the universe might have evolved differently, that time might have stretched or condensed in ways unimagined, felt almost heretical. In the quiet corners of observatories, this conflict unfolded not in arguments, but in silence. The silence of a researcher staring too long at a graph that refuses to make sense. The silence of late-night emails between collaborators half a world apart, questioning their own conclusions. The silence of doubt that settles in when evidence feels both undeniable and impossible. The flickering monitors reflected in weary eyes told a story that was as human as it was cosmic. The story of discovery pressing against the edge of comprehension. Inside this silence, philosophy began to seep into the lab. Science had always been an act of courage, not certainty. To explore the unknown was to live in permanent confrontation with ignorance. To accept that every answer births a deeper question. The astronomers who examined Webb's early data found themselves not just studying the universe, but questioning their own relationship to truth. Could the human mind, bound by time and evolution, truly grasp a reality that began before light itself existed? Were there equations glimpses of the real, or shadows cast by limited understanding? These were not idle questions, they haunted the quiet hours between discovery and publication, between revelation and acceptance. Some scientists became wanderers in this philosophical storm. They spoke in careful tones, aware that every statement could shift the public narrative. They remembered the lessons of history, how early claims, sensationalized and misunderstood, had often turned triumph into confusion. Yet beyond their caution, something deeper stirred. The idea that perhaps this was how science truly evolved, not through perfect predictions, but through disruption. Perhaps the universe was not failing to match the model. Perhaps the model was finally meeting the universe on its own terms. Meanwhile, beyond the laboratories and research conferences, the world began to take notice. Headlines erupted across digital frontiers. James Webb finds galaxies that shouldn't exist. The universe is older than we thought. Physics is broken. Each story simplified the complexity into sound bites of awe and alarm. The public imagination surged videos, articles, and discussions painting scientists as prophets on the edge of cosmic revelation. Yet behind the scenes, those same scientists tread carefully, balancing between the weight of data and the responsibility of truth. To the world, they were visionaries. To themselves, they were custodians of uncertainty. In private meetings, the conversations grew heavier. Senior cosmologists, those who had built their careers on the prevailing model, felt the chill of dissonance. The laws that had once seemed eternal were now trembling beneath the weight of Webb's golden mirrors. For younger researchers, this was liberation, a chance to glimpse something entirely new. For the veterans, it was a quiet reckoning. Theories that had defined lifetimes were being questioned by data collected from a telescope younger than a child. Yet even in disagreement, there was unity in awe. No one could look at those images, the impossible galaxies glowing across. Cosmic nighthand remain untouched. In that fragile balance between pride and humility, between knowing and not knowing, the scientific community revealed its truest form not as a machine of answers, but as a collective of seekers. They were explorers of paradox, guided by curiosity rather than certainty. They were not priests of the known, but pilgrims of the unknown, navigating by the faint light of data that had traveled longer than civilization itself. And so, the debate continued, not in anger, but in reverent wonder. The universe had spoken in riddles once again, and humanity, faithful to its nature, had answered not with finality, but with questions. Because discovery, in the end, is never about finding the truth. It is about learning how to see it, as days turned into months. The tension between certainty and wonder grew into a quiet rhythm that pulsed through every observatory and university hallway. Teams across the globe worked in near silence, connected by invisible threads of curiosity and unease. In small, dimly lit rooms, scientists reprocessed raw data line by line, calibrating redshifts, recalculating distances, searching for flaws that refused to appear. Their screens became windows to epochs, beyond comprehensions, snapshots of creation itself, rendered in infrared hues. And yet, the more they verified, the deeper the paradox grew. The galaxies were real. The ages were real. The contradiction, too, was real. There were moments of exhaustion that bordered on reverence. In the faint hum of server rooms, the air smelled of ozone and coffee and sleepless obsession. Someone would whisper, half to themselves, "It shouldn't be there." Another would respond softly, "But it is." That was how truth often arrived in science, not as thunder, but as a whisper that refused to fade. The universe was not lying. It was speaking a dialect humanity had not yet learned to understand. In the corridors of academia, the human element of discovery unfolded in all its fragile complexity. Senior scientists, their names etched into decades of cosmological theory, stared at new models that made their life's work tremble. Younger researchers, unburdened by legacy, were already sketching new frameworks, bolder, stranger, free from the gravitational pull of the old. Between them, a generational dialogue began to form. It was not rebellion, but renewal. Every discovery in science carried this cycle of death and rebirth of certainty. Collapsing so that truth could evolve, some began to propose daring interpretations. Perhaps the early universe was denser, more efficient at forming stars. Perhaps dark matter clumped faster than predicted, creating gravitational wells that birthed galaxies ahead of schedule. A few suggested entirely new physics, exotic forms of dark energy, time dilation effects, or even varying constants in the primordial cosmos. None of these were certainties, but in their uncertainty lay the essence of progress. It was not that the universe had betrayed the laws of physics. It was that physics itself might be incomplete, still waiting for its next translation. And outside the world of science, the echoes of this intellectual struggle reached millions. For the public, the discovery was a window into the sublime, a reminder that human knowledge, for all its brilliance, was still young. The news headlines painted it as an existential shock, galaxies too old for the universe. Yet beneath the sensationalism lay something purer, rekindled sense of wonder. Children watched the images from James Webb with wide eyes, asking questions their parents couldn't answer. Poets and philosophers wrote of time folding in on itself, of creation rewriting its own prologue. For once, science and imagination were aligned, both humbled by mystery, but within the labs, wonder came with weight. The scientists who bore this discovery carried an invisible burden, the knowledge that they were witnessing something history would never forget, yet could not yet explain. Some felt exhilaration, others a strange grief. To unlearn was as painful as to learn. They were peeling back the veil of reality, only to find another, more intricate veil beneath. Late at night, in moments when the data streams quieted and the stars beyond their windows seemed almost within reach, they would reflect on what it meant to search for truth in a universe that constantly changed the rules. The conflict between belief and uncertainty was no longer something to be resolved, was the engine of discovery itself. The tension between what was known and what was unknowable was not a flaw in science. It was its heartbeat. And so, the community moved forward, not as a chorus of agreement, but as a constellation of voices, each interpreting the same light in a different way. They had entered a new age of cosmology, one defined not by answers, but by the courage to question the very fabric of reality. For in the end, every discovery, no matter how precise, leads back to the same quiet realization that the universe is not a solved riddle, but an eternal dialogue. And through the golden eye of a telescope suspended in darkness, humanity had simply asked its oldest question once again: what are we still not seeing? In the cold, silent depths, beyond the moon's orbit, the James Webb Space Telescope continued its vigil. Suspended in the gravitational balance of the L2 point, its golden mirrors gathered light older than memory itself. Each photon it captured was a relic, an echo from a time when matter first learned how to shine. What emerged from its data was not merely an image, but a revelation that began to challenge everything cosmology once held sacred. The first step was verification. In the discipline of science, doubt is not cynicism, it is devotion. The teams behind James Webb turned to the raw mathematics of redshift, refining measurements with the precision of surgeons. Using the near-infrared camera, UNARCM, and the near-infrared spectrograph, UNARSPEC, they began the slow unraveling of cosmic distance. A galaxy's redshift, the stretching of its light as the universe expands, is a cosmic fingerprint of time itself. What Webb had seen appeared to belong to an age less than 300 million years after the Big Bang. Yet these galaxies shone too brightly, too maturely, as though billions of years had already passed within them. At first, astronomers sought comfort in caution. Maybe the redshifts were off, photometric illusions, artifacts of calibration. But spectroscopy left little room for comfort. The spectral lines were clear, their patterns unmistakable. Each peak and trough of infrared light whispered the same impossible truth. These galaxies were ancient in youth. Their stars, metal-rich and well-formed, defied the timeline of cosmic evolution. Across supercomputer clusters from Cambridge to Tokyo, simulations began to falter. Digital universes, modeled for decades on the CDM framework. The cosmological constant and cold dark matter model refused to replicate what Webb was showing. The earliest galaxies in those simulations formed slowly, meekly, from clouds of hydrogen gas that took hundreds of millions of years to ignite. But in James Webb's data, galaxies appeared already vast, structured, luminous. It was as if cosmic architecture had been fast-forwarded, building cities of stars before the laws of physics had even finished writing their blueprints. Theories began to bend under the weight of evidence. Perhaps dark matter, the invisible scaffolding of the cosmos, was more efficient than imagined, condensing faster, creating gravitational wells that accelerated formation. Or perhaps, as some dared to whisper, dark matter did not behave as cold after all. What if it interacted in subtle, unseen ways, merging and radiating energy in forms not yet understood? If that were true, then the foundation of the cosmic model itself would tremble. Others turned their gaze to the nature of time, the expansion of the universe, that steady stretching of space, described by Hubble's constant, might not be as constant as once believed. If the rate of expansion fluctuated in the earliest epochs, then our perception of cosmic age could be skewed, like looking through a lens of warped glass. Some proposed an even deeper possibility, that time itself flowed differently near the birth of light, curved not just by gravity, but by the very density of creation. For every daring hypothesis, there were cautious rebuttals. Perhaps gravitational lensing, the bending of light by intervening matter, had magnified distant galaxies, making them appear closer and older than they truly were. Maybe there were hidden calibration issues in James Webb's detectors, or noise masquerading as structure. Yet with every reanalysis, the same story emerged. The light was real, the distances accurate, The implications undeniable. Conferences turned into quiet battlegrounds of ideas. In hushed rooms filled with glowing monitors and equations that stretched across whiteboards like constellations of logic. The tension was palpable. Each scientist sought a flaw, a missing variable, a misplaced decimal that could restore order to the cosmos they knew. But the data held firm, like a truth written in starlight. As the evidence mounted, the conversation turned from error to interpretation. Could the first galaxies have been seeded by primordial black holes, dense pockets of matter that collapsed almost instantly after the Big Bang? Could these dark titans have jump-started star formation, igniting the first clusters with their gravitational influence? Or had cosmic inflation, the mysterious burst of expansion that began it all, left behind regions where matter clumped more quickly, birthing galaxies ahead of schedule? Each possibility was as thrilling as it was unsettling. The universe, it seemed, was not only stranger than humanity supposed, it was stranger than it could suppose. Night after night, as James Webb continued to transmit its silent symphony of light, scientists stared into the glow of their screens, realizing that what they were seeing was not just the dawn of galaxies, but the dawn of understanding itself. Every discovery, every recalibrated equation, every refined redshift brought them closer to a single, haunting conclusion that the cosmos was not a finished story, but an unfinished sentence. If the data was true, then something deep within the fabric of reality would have to be rewritten. A fundamental chapter of existence itself awaiting revision. The laws that had once explained everything now whispered that they too might be provisional. The universe was asking to be understood again from the beginning in the weeks that followed. Data continued to stream in like messages from the edge of eternity. Each transmission added another brushstroke to the unfolding portrait of a universe that refused to behave. What was once thought to be a single anomaly had multiplied, a growing family of impossible galaxies, scattered like ancient embers across the black canvas of space. Each one glowed with an age and density that mocked the equations meant to define it. Together, they formed a silent rebellion against cosmological order. Teams of researchers convened across time zones, chasing explanations that slipped like mist through their fingers. Machine learning models were fed the data, cross-checked, recalibrated, reanalyzed, yet the results held with unnerving consistency. The galaxies weren't errors, they were evidence. Their light was authentic, their structure undeniable. Each observation was like another nail in the coffin of cosmic complacency. What had been a comforting narrative of gradual creation, of slow, majestic unfolding now seemed replaced by a universe that built itself in haste, in defiance of its own chronology. At the heart of the confusion lay dark matter, the silent architect of the cosmos, whose invisible gravity guides galaxies into form. But even this mysterious scaffolding seemed to be betraying expectation. For the universe to have birthed these galaxies so soon, dark matter halos would have needed to collapse almost instantaneously, clustering with improbable speed. Some simulations suggested exotic possibilities, self-interacting dark matter, or warm dark matter that moved faster than theory allowed. Others whispered about entirely new physics, forces that acted only in those first flickering moments after creation, then vanished without a trace. Meanwhile, another mystery deepened, the strange presence of heavy elements within these early galaxies. Iron, oxygen, carbon, the fingerprints of stellar death. According to every model, such metals should not have existed so early. They are born in the cores of stars that live and die over millions of years. Their existence meant that entire generations of stars had already come and gone, a cosmic cycle of birth and decay that should have taken eons, yet had somehow unfolded in the universe's infancy. It was as if creation had sprinted rather than crawled, compressing epochs into heartbeats. Theories fractured. Some physicists speculated that perhaps cosmic inflation, the rapid expansion that followed the Big Bang, had produced regions of space where time and density evolved unevenly. Others turned to the concept of variable physical constants, that what humanity calls laws might be local conditions rather than universal truths. What if gravity itself was weaker, or light moved differently in those early moments? If constants could vary, then the universe was not bound by a single clock, but a symphony of shifting tempos in the glow of late-night labs, where coffee cups cooled beside notebooks full of crossed-out equations. Silence often replaced debate. The realization was spreading. They were not merely refining models. They were confronting the limits of human comprehension. For all the telescopes humanity had built, all the equations carved into the language of physics, the universe still held the upper hand. Its design was not a puzzle to be solved, but a presence to be approached with humility. As the days turned to months, the tone of conversation changed. What began as disbelief had evolved into reverence, a quiet awe at the realization that they were witnessing a cosmic truth hidden since the dawn of time. The early universe was not the tranquil cradle once imagined. It was turbulent, restless, alive with forces that outpaced human imagination. Galaxies erupted into existence like sparks from a fire, and black holes, impossibly massive, anchored them before logic could catch up. Each discovery peeled back another layer of mystery, yet none brought closure. The cosmos was expanding, not just in size, but in meaning. It seemed to whisper a deeper message through the silence of light, that creation is not a single event, but a continual unfolding, that the moment of beginning never truly ended. And so the scientists kept looking. They refined, recalibrated, questioned. But beneath the mathematics and the models, an unspoken truth took shape, that perhaps understanding the universe required more than observation. Perhaps it required wonder. For in the flicker of those ancient galaxies, humanity was not just seeing what once was, it was seeing the unending act of becoming itself, written in the language of light older than time, in the silent void beyond the reach of ordinary sight. The Webb telescope drifted, a golden eye suspended in darkness, staring into epochs where reality itself was still being written. With every photon it captured, humanity was peering not merely into the past, but into the blueprint of existence, into the scaffolding of the cosmos as it was being woven together. What it found there challenged even the most sacred principles of cosmic architecture. For the universe, it seemed, had begun its grand construction far earlier and far faster than theory had ever dared to imagine. Through James Webb's gaze, astronomers began to see not isolated galaxies, but entire networks, filaments of light stretching across the abyss, linking clusters in vast cosmic threads. This web, the great connective tissue of the universe, was never supposed to be visible at such an early epoch. According to every model, it should have taken hundreds of millions of years longer for gravity to pull matter into such coherent structures. Yet there it was, faint but undeniable, the first hints of the cosmic web, shining through the haze of the infant universe. It was as though the cosmos had skipped a step, constructing complexity from chaos with impossible haste. At the center of this puzzle stood gravity, the quiet sculptor of the universe, invisible yet omnipresent. For centuries, gravity had been considered a constant companion, its laws immutable from the fall of an apple to the orbit of galaxies. But as scientists looked deeper into the early cosmos, a new thought began to emerge. What if gravity itself was not a constant, but a force that behaved differently when the universe was young, dense, and turbulent? Some theorists propose that in those first moments after the Big Bang, gravity might have been stronger, allowing matter to collapse into galaxies with extraordinary speed. Others wondered whether gravity might not even be fundamental at all, but an emergent property, the byproduct of deeper, quantum principles that governed the very fabric of space-timing in those uncharted depths. The line between quantum and cosmic began to blur. The smallest and the largest scales of reality, the quantum foam and the galactic web, seemed to whisper the same strange truths. Some physicists began to explore models that connected these realms, that perhaps quantum fluctuations, those ephemeral tremors of energy that dance in the void, had served as the seeds of all cosmic structure. The wrinkles in space-time born from quantum uncertainty could have been stretched across the universe during inflation, creating the scaffolding upon which gravity later built galaxies and stars. In that sense, the grandest architecture of the cosmos might trace its origins not to vast forces, but to the trembling uncertainty of the quantum world, a bridge between the infinitesimal and the infinite. Yet deeper mysteries persisted. As James Webb gathered more light, some researchers began to question whether the fundamental constants of physics, those silent rules that shape every interaction, might have been different in those early times. The fine structure constant, which dictates how light interacts with matter, the gravitational constant, which governs attraction, even the speed of light itself. Could they have shifted, ever so slightly, in the first breaths of creation? A change in any of them, however small, could ripple through cosmic evolution like a new rhythm in an ancient symphony, rewriting the tempo of time and the choreography of matter. Such possibilities pushed physics to its edge, to the place where Einstein's smooth fabric of space-time began to fray and quantum uncertainty bled through the seams. Relativity and quantum mechanics, the twin pillars of modern science, still refused to reconcile fully. One ruled the stars, the other ruled the atoms, but neither could yet explain the birth of both. And it was precisely there, in that region where theories faltered and light from the beginning still burned, that James Webb was now looking. Each new image was not just an observation, it was an invitation to rethink the rules themselves. In conference rooms and observatories, the atmosphere grew heavy with both awe and disquiet. Equations once considered stable now seemed provisional. Truths once spoken with certainty now felt tentative. Every new observation from Webb was like a whisper from the cosmos, urging humanity to let go of its assumptions. Perhaps physics, in its current form, was only a language for a small corner of the universe, a dialect suited to the Middle Ages of creation, but not its birth. And yet, in this uncertainty, there was wonder, the realization that the universe, in all its complexity, might still be stranger than imagination itself. The cosmos was not merely expanding outward, it was expanding inward, into the human mind, into the boundaries of what could be known, and at the edge of science, where mathematics gave way to mystery. A new frontier emerged, one where the only map was curiosity, and the only compass, light dot, as the telescope continued its watch, drifting in the stillness of its cold orbit. Humanity found itself facing an ancient paradox in a modern form. The more it understood, the more it saw how little it truly knew. And in that gap between knowledge and mystery, between fact and wonder, science began once again to resemble what it had always been, not the conquest of truth, but the pursuit of it. And so the journey pressed onward, into the extreme edge of the possible, where the first stars still whispered across time, and where imagination, once again, was asked to lead where theory could not. But even as the equations strained to adapt and models were redrawn, the universe continued to speak in a language that defied translation. Every new deep field exposure revealed not silence, but structure, the faint pattern of cosmic geometry written into the darkness itself. Scientists noticed alignments that shouldn't exist, subtle symmetries among galaxies separated by billions of light years, as if some hidden order was guiding their formation. What they were seeing was not chaos, but choreography, a dance whose rhythm seemed older than the universe that contained it. Some researchers turned to the mathematics of emergence, the idea that complexity can rise not from design, but from interaction. Perhaps the early cosmos was a kind of self-organizing system, a living equation where gravity, quantum fluctuations, and the geometry of space-time cooperated in ways no model had yet captured. Others began to ask more daring questions. Could the universe itself possess feedback, a kind of memory written into its own expansion? Could the laws of physics evolve, learning from their own unfolding, as if reality, too, were capable of adaptation? The tension between evidence and understanding deepened. It was no longer just a question of galaxies forming too early. It was a question of whether human perception of time and causality even applied at the cosmic scale. Time, after all, was born in the same fire as space, not an external clock, but a woven dimension within the fabric of the universe. In those first turbulent moments after the Big Bang, when energy and matter were indistinguishable, time itself may have flowed differently, thicker, denser, folding back on itself like molten glass. What Webb might be revealing was not an error in observation, but a glimpse into a region of space-time where cause and effect blurred into simultaneity. In some corners of theoretical physics, whispers of new frameworks began to circulate, ideas that merged relativity, quantum mechanics, and information theory into a single vision. One such framework imagined the universe not as a material construct, but as a vast computation, processing information through every quantum interaction. In that view, the galaxies seen by Webb were not simply matter in motion, but nodes in a cosmic algorithm, structures emerging from patterns of encoded information older than energy itself. The impossible galaxies, then, were not mistakes, but signs that the universe's code was far more intricate than anyone had imagined. Still, not everyone was ready to step into that abyss. To many, these were still speculations born of frustration, beautiful, perhaps, but untested. Yet the allure of mystery proved stronger than caution. The farther humanity looked, the more it saw reflections of itself, curiosity mirrored in the chaos, structure emerging from uncertainty, meaning born from mystery. The galaxies at the edge of time were no longer distant objects of study. They had become symbols of a deeper question about the very architecture of existence, and whether reality, as science defined it, was complete. Back at the Elta Point, the Webb telescope continued its vigil, its segmented mirrors catching the cold light of creation. Every photon it absorbed was older than the Earth, older than stars, older even than the dust from which humanity came. And in that light, something profound shimmered, a reminder that science is not a conquest of nature, but a communion with it. The telescope was not merely looking outward. It was listening to the hum of the cosmos, to the echo of beginnings, to the pulse of a universe still writing its own story. Perhaps that is the true purpose of exploration, not to define the universe, but to be changed by it. For at the edge of knowledge, where the galaxies grow strange and the equations dissolve into silence, something else awakens, a quiet reverence, a recognition that existence itself is not a solved problem, but an open question. And there, in the reflection of those impossible worlds, humanity glimpses not just the origin of the cosmos, but the infinite evolution of its own understanding. In the halls of modern astronomy, where the hum of data servers replaces the ticking of clocks, a cautious optimism began to take hold. After months of disbelief, the first wave of explanations emerged, careful, methodical, and grounded in the familiar. If the galaxies James Webb had found appeared too massive, too luminous, and too evolved for their age, perhaps the problem wasn't the universe itself, but humanity's expectations of it. The cosmos, after all, had surprised scientists before. It would not be the first time that human understanding lagged behind the universe's quiet genius. One theory began to gather momentum, that the early cosmos was far more efficient at forming stars than anyone had imagined. In the dense fog of the young universe, clouds of hydrogen may have cooled faster, collapsing into stars at a breakneck pace. Perhaps the cosmic recipe was simply different then, with gas clouds richer, pressures higher, and cooling processes more aggressive. If so, then the birth of the first stars could have unfolded not over hundreds of millions of years, but in tens of millions, a cosmic blink. This would explain the blinding brightness of those early galaxies, their apparent maturity, a trick of accelerated evolution. But other voices argued that even this could not fully account for what was seen. The galaxies captured by Webb did not merely shine brightly. They exhibited complexity, spiral arms, structured disks, elements that hinted at multiple generations of stars. To achieve such organization so soon after the Big Bang seemed improbable by star formation alone. So attention turned to something more dramatic: mergers in the young universe. Gravity was a relentless sculptor, pulling matter into denser knots of structure. Proto-galaxies, barely formed, could have collided in a cosmic frenzy, fusing their masses together in violent unions. These collisions would have accelerated growth, creating massive galaxies in record time. The early universe may have been far less tranquil than once believed, a realm of chaos and collision, where light itself struggled to escape the debris of creation. In this vision, the first galaxies were not graceful spirals, but roaring furnaces of dust and fusion. Their beauty, born from violence, dark matter, too, re-entered the conversation. For decades, it had been the invisible framework of cosmology, unseen, yet undeniably present. Some theorists propose that dark matter may have clumped earlier and more efficiently than expected, drawing in normal matter at an accelerated rate. If these invisible halos formed sooner, they could have acted as gravitational wells, birthing galaxies faster than visible models could explain. James Webb's discoveries, then, might not be anomalies at all, but evidence that the hidden half of the cosmos, the dark half, was more dynamic in its infancy than previously known. Still, skepticism persisted. Could these galaxies truly be as old as they appeared? Or was perception itself being deceived by the medium through which that ancient light had traveled? Interstellar dust, some argued, could distort and redden the light, mimicking the spectral signature of high redshift, making galaxies seem farther and older than they were. A subtle illusion, born of cosmic dust, might be tricking even the most advanced instruments. This hypothesis carried a poetic irony, that the universe's oldest mysteries might not lie in the depths of space, but in the filters through which humanity sees them. Then came another line of thought, feedback mechanisms. In the modern universe, black holes and supernova regulate the pace of galaxy growth, blowing out gas and quenching star formation. But in the early universe, those feedback loops may have worked in reverse. Instead of slowing creation, they could have compressed it, shockwaves from supernova and nascent black holes igniting new stars with furious efficiency. The cosmos, in its youth, might have been caught in a runaway feedback loop, a chain reaction of light and gravity feeding upon itself, until entire galaxies ignited in what could only be described as cosmic adolescence, rapid, volatile, and breathtakingly bright. Yet even as these explanations took form, something remained unsettled. Each theory patched one gap while exposing another. If the galaxies were products of mergers, why were they so orderly? If star formation had simply accelerated, what force had triggered the change? If dark matter clumped early, what governed its behavior? Science was finding answers, but none that felt complete. The pieces fit, but the picture they formed still seemed off-center, incomplete, as though something essential remained hidden between the equations. In conferences and publications, the tone grew cautious. Phrases like tentative solution and possible interpretation filled the language of discovery. The community was learning to balance awe with restraint, to acknowledge that the early universe was not merely older or younger than expected, but stranger and perhaps more creative than the human mind could easily define. Still, within that uncertainty, there was a strange beauty. The act of theorizing itself, of reaching, recalibrating, and daring to question the foundations of knowledge, was a reflection of the very process that shaped those distant galaxies. Creation, whether cosmic or intellectual, thrives in instability. In the spaces where certainty falters, new worlds and new ideas are born. As the chapter of mainstream explanations unfolded, a quiet realization began to echo across observatories and universities. These were not definitive answers, but acts of survival, the mind of humanity reaching to preserve its framework against the oncoming tide of the unknown. Because deep down, every scientist could sense it, that behind the polished equations and reinterpreted data, there still lingered something unexplainable, something that refused to be tamed by logic alone. And so, even as papers were published and conferences adjourned, the real mystery remained intact. The galaxies still shone in defiance of reason, their ancient light crossing time not merely to inform, but to challenge, to whisper that the universe was not finished being strange. And for some, that whisper was not comforting. It was haunting, a signal that the cosmos was keeping secrets far older than science, waiting for those bold enough to see beyond the safety of theory. For as elegant as the fixes seemed, many began to sense what few dared to say aloud, that perhaps these explanations were not revelations at all, but patchwork, temporary veils over a truth far deeper and far more unsettling than anyone yet understood. Beneath the surface of these debates, a quiet unease began to settle over the scientific community, a tension not born of disagreement, but of recognition. Each new model, each refined simulation, seemed to bend the data just enough to make it fit, but not enough to satisfy the deeper question that pulsed beneath it all. Why? Why would the universe, so young and chaotic, arrange itself into harmony so soon? Why would galaxies' colossal engines of gravity and radiation emerge with such grace from the raw furnace of the Big Bang? The revisions sounded plausible, yet carried the hollow echo of convenience. It was as if the universe were politely allowing humanity to adjust its understanding, while quietly guarding its deeper truths. Astronomers ran simulations that stretched supercomputers to their limits, feeding in new parameters for dark matter distribution, star formation, efficiency, and baryonic cooling rates. But the models, no matter how intricate, refused to recreate what James Webb had shown. The early galaxies remained too massive, too structured, too ready. Nature was performing a choreography far more complex than the equations could capture. Each failed simulation felt like a message that perhaps the framework itself was incomplete, or worse, founded upon assumptions the universe never agreed to. In some corners of the field, a more radical idea began to stir, whispered in the margins of research papers, discussed cautiously in private symposiums. Perhaps these galaxies were not breaking the rules. Perhaps the rules themselves were never fully written. Could it be that the physical constants, the seemingly immutable numbers that govern the behavior of energy and matter, were not fixed in the early universe? A small variation in the fine structure constant, or the speed of light, could ripple across the fabric of physics, rewriting the pace of time, the strength of gravity, the birth rate of stars. It was a hypothesis, both thrilling and terrifying, that reality itself might have been a shifting stage in its infancy, still settling into the laws that would later define it. Others turned their gaze toward the interstellar dust again, not as a nuisance but as a storyteller. Dust was ancient, forged in the hearts of dying stars, scattered across space like cosmic memory. It could distort the light, yes, but it could also preserve secrets about the environments from which that light had come. By studying the spectra of these distant galaxies, astronomers began to detect unusual chemical fingerprints, elements, like oxygen and carbon appearing where they shouldn't exist yet, whispering of stellar cycles that had already come and gone before the universe was 1 billion years old. If these readings held true, then the cosmos had lived, evolved, and died faster than any model dared predict. And still, amid this swirl of ideas, one truth glimmered through the uncertainty: that James Webb had not simply observed galaxies, but time itself in its most volatile state. The telescope had become a window into a reality that was still being written, where matter and energy were locked in a race to define what existence meant. Theorists could refine, reinterpret, and reframe, but each adjustment seemed only to illuminate the depth of the mystery, not resolve it. There was something profoundly human in this process, this dance between curiosity and limitation. The scientists staring at James Webb's data were not merely interpreting numbers. They were confronting the edges of meaning, grappling with the realization that the universe was not obligated to make sense on human terms. Every equation was a question posed to the cosmos, and every unanswered one a reminder of how young humanity's understanding truly was. As months turned to years, the discourse shifted from disbelief to acceptance, and from acceptance to wonder. The universe, it seemed, was not broken. It was simply more ambitious than anyone had imagined. It did not follow the neat timelines carved by textbooks, nor the comforting logic of cosmic order. Instead, it unfolded like a story written by forces older than reason, where gravity, light, and time wove themselves into patterns still beyond reach. And so, the chapter of leading theories closed not with certainty, but with humility. The scientists, armed with the most advanced technology in history, found themselves once again at the threshold of the unknown. The early galaxies continued to shimmer in the deep sky, silent, ancient, unyielding, their light crossing 13 billion years to remind those who watched that understanding was not a destination, but a pursuit. For every answer, the universe offered a deeper question, and for every theory, it whispered a single, timeless truth that perhaps the cosmos was never meant to be solved, only witnessed. In awe, in the dim glow of data screens across observatories and universities, a quiet rebellion began to take shape, not against science itself, but against the boundaries it had built. The discoveries of James Webb had carved a fault line through the bedrock of modern cosmology, and through that crack, the wildest possibilities began to spill forth. For centuries, physics had marched forward with disciplined precision, its equations like verses of an ancient hymn sung in harmony with the universe. But now, the melody faltered. Something in the early cosmos refused to conform. And so, the theorists turned to the edges, to the speculative, and the strange, searching for meaning. In the silence between the stars, among the first to challenge the cosmic tempo were those who questioned light itself. Since Einstein, the speed of light had been treated as sacred, the ultimate constant, the rhythm that time itself followed. But what if it hadn't always been so? The variable speed of light hypothesis dared to suggest that, in the first instance of creation, light may have moved differently, faster, freer, unbound by the laws that later crystallized reality. If true, the young universe could have evolved with astonishing speed, allowing galaxies to form sooner than predicted, time itself flowing through a more fluid continuum. It was a daring thought, and to some, a dangerous one, for it meant that even the foundation of relativity might have been merely local, a chapter in a much larger cosmic story still unfolding. Then came the theorists of gravity, the architects of invisible forces. They argued that perhaps dark matter was never there to begin with, that what James Webb was seeing wasn't a failure of observation but a flaw in the theory itself. Modified Newtonian dynamics, or MOND, had long been dismissed as an outsider's dream, a tweak to gravity's strength on the grandest scales. But with James Webb's revelations, whispers of reconsideration returned. Maybe gravity behaves differently across vast cosmic distances, stretching its influence in ways not yet captured by equations. Theories like Thieves' tensor vector scalar gravity emerged as attempts to bridge the gap between Einstein's elegance and the universe's chaos. If the galaxies of the early universe truly formed too soon, perhaps it was gravity itself that lent them its unseen hand, bending not just space, but the rules of formation. And yet, beyond the realm of physics, some began to ask questions, even stranger questions, that blurred the line between science and philosophy. Could these galaxies, these impossibly ancient islands of light, be artifacts of something deeper, errors not in observation, but in reality itself? The simulation hypothesis, once confined to late-night thought experiments, found new relevance. In a simulated universe, early galaxies might appear older, larger, or inexplicably stable, not because of broken physics, but because of the architecture of code, a cosmic rendering trick. It was an idea that danced between awe and unease, that the universe might not be a stage of matter and energy, but a performance of information, unfolding according to algorithms far beyond comprehension. Others turned their gaze backward, not to the beginning, but to before it. The cyclic models of the cosmos suggested that the Big Bang was not the first spark of existence, but merely the latest in an infinite sequence of cosmic rebirths. In this vision, each universe is born from the ashes of the one before, expanding, collapsing, and expanding again in a rhythm as old as time itself. If this were true, then perhaps the galaxies, James Webb observed, were not anomalies at all, but echoes, spectral imprints of a prior cosmos bleeding through into the next. It was a hauntingly beautiful notion, that the light crossing the void might carry not just the story of this universe, but the memories of others long dead. And still, even these daring ideas found themselves confronted by a deeper strangeness, one rooted in the quantum foundations of reality. Some physicists began to suspect that space-time itself was not a smooth, continuous fabric, but an emergent phenomenon, born from entanglement, the invisible threads connecting particles across distance and time. If true, then the geometry of the universe, its expansion, and even its ancient structure might arise not from forces, but from relationships, a vast cosmic network of information weaving itself into being. The galaxies of the early universe, so perfectly arranged, could then be the first visible patterns of that quantum web, the moment when connection became creation. Each of these theories, from the measured to the metaphysical, sought not to explain away the mystery, but to illuminate it from new angles. And yet, as the possibilities expanded, so too did the distance from certainty. For every model that seemed to bring clarity, another unfolded that deepened the shadows. The universe was not offering answers, it was inviting interpretation, challenging the very notion that truth must be singular. In conference halls and observatories, the tone of debate shifted. What had begun as a quest to reconcile data had become something more profound, a meditation on the limits of knowledge itself. James Webb had not simply revealed ancient galaxies. It had forced humanity to confront the nature of reality. Was the cosmos a machine of laws and constants, or a living, evolving entity, still learning its own structure? And so, the speculative frontier stretched onward, not as a retreat from science, but as its evolution. Each theory opened a door, and behind each, the mystery only deepened. Somewhere beyond those golden mirrors, light still traveled through the endless dark, carrying not just the story of what once was, but the echo of questions yet unasked. As more light poured in from James Webb's golden eyes, the speculative frontier widened like the ripples of a stone cast into a boundless sea. Each observation was a spark, igniting fresh rounds of debate in the halls of cosmology, debates that no longer centered merely on data, but on the very philosophy of existence. It was as if the universe, once thought to be a solved equation, had begun to write in a language no one could yet read. The models that once promised order now trembled under the weight of new evidence, and for the first time in generations, even the most steadfast scientists whispered of mystery with reverence rather than resistance. In the quiet hours of research, centers across the globe, screens glowed like modern campfires around which humanity once again told stories of creation. What was once myth, the primordial struggle between chaos and order, had returned, now draped in the cold mathematics of quantum fields and relativity. Theories that once existed on the periphery began to take on unexpected gravity. A few voices suggested that perhaps constants, such as Planck's constant, the gravitational constant, or the fine structure constant, might have evolved in the early epochs. If even one of them had drifted slightly from its present value, the entire framework of cosmic history could have unfolded differently. Stars could have burned faster, atoms could have fused sooner, and galaxies might indeed have matured long before they were meant to. It was a seductive idea that the cosmos itself might be dynamic not only in space and time, but in its very laws. Others began weaving bridges between quantum strangeness and cosmic scale. The concept of quantum entanglement, that two particles can share a state across vast distances, took on a more profound meaning when applied to the universe itself. Perhaps, they mused, the earliest structures were not formed through gravitational collapse alone, but through quantum coherence, a vast, universe-spanning resonance that organized chaos into form. If the cosmic web emerged from such entanglement, then the galaxies James Webb observed could be seen not as violations of physics, but as the first harmonies in a symphony of universal connectivity. Reality, in this light, became not a thing but a process, an ever-expanding pattern of relationships, each echoing the invisible structure beneath existence itself. And yet, the deeper the theories reached, the more the boundary between science and metaphysics began to blur. Some physicists, once grounded in empiricism, found themselves speaking of consciousness and perception. They pondered whether the act of observation, of measuring and interpreting ancient photons, played a role in shaping what was seen. Could reality, at its deepest level, be participatory? Could the universe, in some subtle way, respond to the gaze of those striving to understand it? The notion was not new. It had echoed in the quantum paradoxes of the 20th century. But now, under the gaze of James Webb, it felt newly relevant, as if the telescope itself, through its gold-plated eyes, had become a participant in the universe's unfolding awareness. Meanwhile, the notion of a multiverse gained new traction. If our cosmos was but one bubble among countless others, then perhaps James Webb's impossible. Galaxies were glimpses of cosmic bleed through light, leaking across boundaries not meant to touch. In string theory's higher dimensions, or in the cyclic churn of eternal inflation, universes might collide, overlap, or exchange energy. The early galaxies could be scars of that ancient encounter, evidence not of broken models, but of a grander architecture that spans beyond comprehension. These ideas, though daring, were not born from fantasy. They were born from the same spirit that had driven every leap of understanding, from Newton's apple to Einstein's relativity, from Hubble's expanding universe to James Webb's golden revelation. Each new paradigm had once been heresy. Each discovery had required faith, not in dogma, but in the courage to question it. And now, in the face of light older than galaxies, that courage was being tested again, for as the theories multiplied, so too did the awe. The more humanity uncovered, the more apparent it became that knowledge did not conquer mystery, it expanded it. Every answer was a horizon receding into greater depth, every equation a window opening onto infinity. Somewhere beyond the edge of comprehension, beyond the reach of James Webb's mirrors and mankind's mathematics, the universe continued its quiet creation, timeless, patient, unbothered by the urgency of those who sought to define it in that vast silence. One truth shimmered brighter than all others. Perhaps the cosmos was never meant to be fully understood. Perhaps its design was not a puzzle to be solved, but a mirror reflecting the limits and the wonder of the human mind itself. In the quiet hum of deep space communication networks, humanity's greatest eye continues its vigil. The James Webb Space Telescope still drifts at its Lagrange perch, balanced delicately between gravity and nothingness. Its golden mirrors open like the petals of a celestial flower facing the ancient light. Each photon it captures travels not only through the void but through time itself, a silent courier from the beginning of creation. And still, with every image it sends back, the mystery only grows deeper. New, deep-field surveys, denser, longer, and more detailed than ever before, reveal not the answers scientists hoped for, but new riddles etched into the darkness. Galaxies crowd the edge of cosmic dawn, shimmering with impossible maturity, while their light curves whisper of events far beyond the reach of current models. James Webb's spectroscopic instruments, designed to peel apart the faint fingerprints of elements, continue to confirm the improbable hydrogen, helium, and the glimmers of heavier elements. Far too soon after the supposed birth of time, the early galaxies, once thought to be rare anomalies, are now joined by dozens more. Ceres 93, Glassy 1-3 Maisie's Galaxy, and countless unnamed smudges in the abyss each tell a similar tale. Spectroscopy confirms their distances. The light curves confirm their masses. The verdict is unavoidable. The early universe was not quiet. It was ablaze with structure, creativity, and contradiction. These findings echo through scientific circles like the tolling of a great bell, a sound not of finality, but of awakening. Observatories on Earth, from Chile's Atacama to Hawaii's Mauna Kea, now aim their instruments toward these coordinates, chasing photons first released when reality itself was still soft with creation. The collective effort has transcended borders, institutions, and even disciplines. Astronomers, physicists, and philosophers now share the same table, united not by certainty, but by wonder. Meanwhile, preparations for the next era have already begun. The Nancy Grace Roman Space Telescope, once envisioned as a mere successor to Hubble, now stands poised to become a bridge between James Webb's revelations and the unknown frontier beyond. Its vast field of view will allow it to scan entire sections of the early universe at once, transforming single discoveries into cosmic statistics. On the ground, the European Extremely Large Telescope, with its 39-meter mirror carved from glass and ambition, prepares to peer deeper into cosmic dawn from the dry plateaus of the Atacama Desert. The square-kilometer array, stretching across continents, will map the invisible web of hydrogen that once filled the universe like a fog before the stars burned it away. Together, they form a chorus of instruments, each designed to listen to a different note in the universe's ancient song. In research centers and observatories across the world, computers now serve as extensions of imagination. Simulations once constrained by assumptions are being rewritten entirely. Teams of cosmologists feed James Webb data into new frameworks, letting artificial intelligence sift through millions of possible universes to see which laws could give rise to the one we observe. The CDM model, the backbone of modern cosmology, still stands, but not unshaken. Its constants, once sacred, are now treated with renewed humility. Supercomputers like Frontier and Summit generate universes in silico, watching them evolve across billions of simulated years in the span of hours, searching for patterns that match the real cosmos. Some runs collapse into featureless voids. Others blossom into galaxies too early, too fast, just like James Webb's findings. And within that digital tension lies the growing recognition that perhaps the universe itself is not bound by our mathematical instincts. For all its technology and precision, modern cosmology now finds itself returning to its philosophical roots. The universe, once mapped with equations, has become a mirror reflecting the limits of human perception. Science has always been an act of faith, not in the supernatural, but in the belief that the cosmos is knowable. Yet every breakthrough reveals how much remains hidden, how the frontier recedes with every step forward. The revision of understanding is no longer seen as failure, but as evolution, the natural rhythm of discovery. Scientists now speak of theories not as walls, but as scaffolds, temporary frameworks to reach higher truths before they are dismantled and rebuilt anew. And perhaps this is where the beauty lies, in the acceptance that the universe is not static, nor is our understanding of it. Each discovery is not a final word, but a continuation of a sentence written across time and space. James Webb did not simply find galaxies. It found the pulse of cosmic creativity, evidence that the universe itself is far more dynamic, far more alive than anyone dared to believe. As the data continues to pour in, the world watches not for closure but for expansion of knowledge. of imagination, of humility, because beyond the data, beyond the theories and the cold precision of instruments, lies something ineffable, the reflection of humanity itself in the cosmos. In the end, every lens turned outward becomes a mirror turned inward. Each galaxy is both a relic and a prophecy, a reminder that the search for the beginning of everything is, in truth, the search for meaning within ourselves. And somewhere, far beyond the reach of even the Webb's golden mirrors, the universe continues to write its silent story, a story humanity can read only by learning to listen to the light. And yet, amid this flurry of progress and precision, a quiet unease lingers beneath the triumph. The further James Webb peers, the less certain the ground beneath theory becomes. In the dim glow of laboratories and data centers, the faces of scientists reveal the paradox of their work, exhilaration laced with humility. For every dataset that refines a redshift, another raises a contradiction. For every elegant equation that explains a curve of light, another equation unravels under its own complexity. It is as though the cosmos is speaking in a dialect just beyond human comprehension, a language of patterns glimpsed but never fully translated. And still they listen. Night after night, the observatory teams monitor streams of photons older than the Milky Way itself, sifting through the faint echoes of creation in search of coherence. At NASA's Goddard and ESA's data hubs, collaboration has evolved into something unprecedented. Datasets once guarded by individual teams are now shared across continents in real time. Algorithms trained on billions of light years of structure learn to detect anomalies that human eyes would overlook. Machine learning now acts as an interpreter between the telescope and the human mind, tracing faint arcs of distant light that might reveal hidden galaxies behind the glare of brighter ones. Every discovery, every confirmed redshift, every refined stellar mass is cross-verified, debated, and integrated into the collective effort to redefine what early means in cosmic terms. There is a new kind of science emerging here, one that is less about asserting certainty and more about surrendering to the unknown, trusting that even contradictions carry truth if read with patience. The atmosphere in cosmology today resembles the threshold of a paradigm shift. Some researchers suggest that perhaps what James Webb sees is not a crisis at all, but a revelation, an unveiling of processes that were always there, hidden beneath the limits of earlier instruments. Others argue that it points to something more radical, a hint that the laws of physics themselves may have evolved. In a sense, both may be right. The act of observation does not just expose the universe, it transforms the observer's understanding of reality. James Webb has not broken physics, it has shown that physics was never finished. New missions now form a constellation of ambition. The Euclid telescope, launched to map dark energy and cosmic structure, will complement James Webb's deep vision with a wide sweep of context. Together with the Roman telescope's future surveys, they will begin to map the architecture of the cosmos not as a static structure, but as a living organism, pulsing, growing, and adapting through epochs. Each mission builds upon the last, as though humanity were constructing a ladder made of light, one photon at a time. But the most profound change may not lie in the hardware, nor even in the data, but in the hearts of those who interpret it. In a time where science often competes for attention in a noisy world, James Webb's discoveries have rekindled something ancient, awe. It is the same awe that once drew early astronomers to sketch the heavens by candlelight, the same reverence that ancient storytellers felt as they mapped constellations into myths. The telescope has reminded the modern world of something that equations alone cannot capture, that the universe is not merely a mechanism, but a mystery that welcomes humility. And so, as the final data sets of each night arrive, streams of photons, turned into meaning, scientists and dreamers alike are drawn to the same realization. The search for the earliest galaxies, the effort to model their impossible brightness and unthinkable age, is not just about rewriting cosmic history. It is about understanding the present, this fleeting moment in which consciousness gazes upon its own origins. The same light that once illuminated the first stars now falls upon the human retina, bridging billions of years with a single act of perception. In that sense, every observation becomes an act of communion between the cosmos and the minds born within it. And so, as James Webb continues its silent watch, humanity stands at the edge of a new chapter. Not one of conclusions, but of continuity. The instruments may one day fade, their gold mirrors dulled by time, but the light they captured and the questions they inspired will echo forever. For science, in its purest form, is not the conquest of mystery. It is the reverent acknowledgement that mystery is what keeps the universe alive. In the quiet aftermath of revelation, the cosmos feels almost sentient, as if aware of the shock it has stirred within the minds that gaze toward it. The impossible galaxies, once thought to break the rules of reality, now hang suspended in the stillness of comprehension's edge. They are not intruders in cosmic order, but invitations, delicate reminders that knowledge itself is fragile, that every equation, every law, is but a reflection of our current capacity to see. Science has always been humanity's attempt to place structure upon infinity, to draw lines on the surface of a storm. Yet each time those lines are drawn, the universe gently erases them, whispering that the truth is far larger, more intricate, more alive than the minds that chase it. Certainty, it seems, is not a summit to be reached, but a mirage on the horizon, dissolving the closer one comes, and in that realization, something profound unfolds. The universe ceases to be a distant object of study and becomes a mirror. Every mystery it reveals, every anomaly, every paradox, reflects not just the cosmos, but the limits of human imagination. Those galaxies that shouldn't exist are not mistakes in nature, but revelations of perception. Perhaps the laws were never broken. Perhaps it was human understanding that had yet to stretch far enough to encompass them. To look upon the ancient light of a galaxy that formed too soon is to confront the possibility that time itself is more fluid than we once believed, that causality and chronology may weave and loop, like rivers doubling back through unseen valleys. What we call the past might not be behind us at all, but layered around us, folded into the very structure of reality like pages in a book written in 4 dimensions. As this thought lingers, the image of time begins to dissolve into something far more poetic. The cosmos is not a ticking clock, but a breathing organism exhaling stars, inhaling silence, pulsing in patterns beyond the measure of years. Galaxies may rise and fade, but in their birth and death lies a symmetry that transcends chronology. Every photon that reaches a telescope's mirror carries not just information, but memory, the echo of existence itself. These impossible galaxies are not merely old. They are storytellers, preserving the early verses of a cosmic poem still being written. And in decoding their light, humanity is not simply reading the past, it is participating in it.